Pseudo-classical decorators. We're now going to examine a variation of the decorator first presented in JavaScript from Pro JavaScript Design Patterns by Dustin Diaz and Ross Harmes. Unlike some of the previous examples, Diaz and Harmes stick more closely to how decorators are implemented in other programming languages such as Java or C++ using the concept of an interface, which we will define in more detail shortly. So aside from those MacBook and the class example, there's people show this or explain this decorator concept in light of other programming languages such as Java and C++, which is actually makes this decorator more complex and hard to use, as we will see later. These particular variations of the decorator pattern is provided for reference purposes. If you find it overly complex, I recommend opting for one of the straightforward implementations covered earlier. PJDP describes the decorator pattern as one that is used to transparently wrap objects inside other objects of the same interface. So it describes that as that specific instance in your runtime code as wrapping an object inside other object of the same interface. An interface is a way of defining the methods an objects should have. Kind of like with TypeScript, when you're defining an interface, you're defining a member that those objects should have. And also, interface is another way of saying another form of method. However, it doesn't directly specify how you should implement those methods. Like it doesn't provide you like the implementation or the how. It just provides you the properties or member declaratively. Interfaces can also optionally indicate what parameters the methods take. So optionally, it can indicate what parameters the methods take, kind of like how member types should accept, how members should accept type, but not the implementation, like what type is allowed on those members inside the interface, and whether it's optional or required. So why would we use an interface in JavaScript? The idea is that they're self-documenting and promote reusability. In theory, interfaces make code more stable by ensuring any change to the interface must also be propagated to the objects implementing them. So in theory, it's kind of like how you would hide the complex implementation in a simple interface, and it acts like a variable as well, kind of like a variable in which one change allows you to change many values or many propagated values in the system. Now what follows is an example of implementation of interfaces in JavaScript using doc typing. This approach helps determine whether an object is an instance of a constructor or object based on the methods it implements. So this interface basically allows you to determine if an object that you will pass into it is an instance of an object or a constructor based on the methods or based on the member that it implements. So this is what this interface function is, or this is what it is used for. First, we will create interfaces using a predefined interface constructor that that accepts an interface name and skeleton methods to expose. So since we need to define an object or a constructor based on its method, we need to accept that into our interface as well. Now we're gonna create that interface that will accept that. So in our reminder example, summary function and placeholder function represents functionality the interface should support. So here we have const reminder equal new interface argument list comma parameter summary comma place order. So in here in this reminder object or interface, we basically have the functionality summary and place order that this interface must require or must fulfill. Now after that, const properties equal member name with the value remember to buy the milk, comma member date with the value 5/6/2040, comma member actions inside of this our value of this actions is an object, and an object with summary function that return remember to buy the milk, we are almost out, and then another placeholder member function with the value return ordering milk from your local grocery store. So think of this action object has a value of another of an object, so it's kind of like object within an object that has value of an object that has two member, that is a function which is summary and placeholder, and then closing. Now create a constructor implementing these properties and methods like class to do inside this constructor with the parameter actions and name inside interface that ensure implements parameter actions comma remainder closing. Then next we redefine the name, this dot name equal name closing, this dot methods equal actions closing. So what does this code does is it state the methods we expect to be supported, which is the actions and the name, as well as the interface instance being checked against. So it checks the interface instance that being checked against, such as here interface that ensure implements action comma reminder. Then we create a new instance of our to do constructor. Const to do item equal new to do parameter properties. Finally, test to make sure this functionality correctly. Console.log to do item that methods that summary function closing. Then console.log to do item that methods that placeholder closing. Now it outputs remember to buy the milk. We're almost out. Then ordering milk from your local grocery store. Both classic JavaScript and ES 2015 Plus do not support interfaces. However, we can create our interface class. So the old and new JavaScript do not have a built-in interface class, unlike with TypeScript, but we can create our interface just like this. So as we can see here, we check an object against an object to make sure it implements those methods, and we use we create an interface for us to check that method using interface that ensure implements. In the previous example, interface that ensure implements provides strict functionality checking, and you can find code for both this and the interface constructor. So you can find both for the one or for the function that check the methods and for the constructor such as constructor parameter, object actions, comma name. The main concern with interfaces is that JavaScript does not have built-in support for them, which may lead to attempts at emulating features from other language that might not be an ideal fit. However, you can utilize TypeScript if you really need interfaces, as it provides built-in support for them. Lightweight interfaces can be used without a significant performance cost in JavaScript, and we will explore abstract decorators using the same concept in the following section. So you can actually implement this type of interface and make it lightweight without a significant cost in your JavaScript performance. So one abstract decorator is actually the one being used to implement this lightweight, which we will discuss now. So abstract decorators, to demonstrate the structure of this version of the decorator pattern, we're going to imagine we have a superclass that models a MacBook once again, and store that allows us to decorate our MacBook with a number of enhancements for an additional fee. So we need kind of like a superclass or a base class and a store that allow us to decorate that base class with a number of enhancement for an additional fee to demonstrate how this abstract decorator works. Enhancement can include upgrades to 4 gig or 8 gig of RAM. This can be much higher now, of course. Engraving, parallels, or a case. Now, if you were to model this using an individual subclass for each combination of enhancement options, it might look something like this. Const MacBook equals to class and then closing. Then these are the subclass. Const MacBook with 4 gig RAM equal class. Closing again, and then const MacBook with 8 gig RAM equal class. Empty class object closing. The same with the superclass and the 4 gig RAM, and const MacBook with 4 gig RAM and engraving equal again empty class. Then etc. until I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 subclass and so on. The solution would be impractical because a new subclass would be required for every possible combination of enhancements that are possible. So again, it's solving that combinatorial explosion. As we would prefer to keep things simple without maintaining a large set of subclasses, let's look how we can use decorators to solve this problem better. Rather than requiring all of the combinations we saw earlier, we will create only 5 new decorator classes. Methods called on these enhancement classes would be passed on to our MacBook class. So instead of creating all of those, we will just create a 5, and then method that will tap into this 5 would be passed on to the superclass or our abstract class, which is the MacBook class. In the following example, decorators transparently wrap around their components and can be interchanged as they use the same interface. So now, these decorators wrap around other decorators or subclass that can be interchanged as they use the same interface or they use the same subclass. So here's the interface we're going to define for the MacBook. Const MacBook equal new interface, parameter first MacBook, comma, and then an array. First the add engraving, comma, add parallels, comma, add 4 gig, comma, add 8 gig RAM, and comma, add case, comma, closing. So these are the subclasses we will just we wrap around. So these are the subclasses that we wrap around their components and can be interchanged. And then we create a class MacBook Pro. So a MacBook Pro might thus be represented as follows: class MacBook Pro, open and closing semi-curly. So that's inside. It's the implementation of MacBook. ES 2000 plus 15 plus, we still could use object.prototype for adding new methods because internally we use the same structure. Now after that class, we define that closing class MacBook closing. After that, MacBook Pro that prototype equal open semi-curly bracket. Inside is an add gravings function with an empty object, comma, add parallels function, empty object, and then 4 gig RAM, 8 gig RAM, add case, and then get price. So for get price, inside of this object, so we don't have empty object anymore, we have base price return 900.0 semicolon closing. So to make it easier for us to add many more options as needed later on, an abstract decorator class is defined with default methods required to implement the MacBook interface. So to make it easy and to provide more option later on rather than doing this, we're actually creating an abstract class with the default method to implement those MacBook interface that other components can use, which the rest of the options will be subclass. So abstract decorators ensure that we can decorate a base class independently with as many decorators as needed in different combinations. Remember the example earlier, without needing to derive a class for every possible combination. Like this class MacBook decorator, inside this constructor parameter small lowercase MacBook, inside this interface that ensure implements parameter MacBook parameter small lowercase MacBook, comma, uppercase MacBook closing, then this that MacBook equal MacBook closing, and then after that, inside still inside in this class is add graving function. Inside return of this object, return this that MacBook that engraving function closing, then add parallels function. Then inside this object returns that MacBook that add parallels function, and then 4 gig RAM, 8 gig RAM, add case, get price. So it's the same pattern, then closing. In this sample, the MacBook decorators accept an object, a MacBook, to use as our base component. It uses the MacBook interface we defined earlier. So here, this is actually a decorator, which define MacBook as its base component, which here we define as const MacBook on new interface. It uses the MacBook interface we defined earlier, and each method is just calling the same method on the component. We can now create our option classes for what can be added using the MacBook decorator. So let's now extend or decorate the case decorator with the MacBook decorator. So class case decorator extends MacBook decorator inside this constructor parameter lowercase MacBook, and then opening object semi-curly or object super inside this object you call super parameter MacBook closing, and then add case function with an object that return $sign this that MacBook that add case function, add case to MacBook closing, then closing the next line get price function, then inside is return this that MacBook that get price plus 45.0, then closing. We are overriding the add case function and get price methods that we want to decorate, and we're achieving this by first calling these methods on the original MacBook and then simply appending a string or numeric value EF45 to them accordingly. So we're able to override the add case and get price methods on our parent class or abstract class that we want to extend, and we're achieving this by concatenating or by first calling these methods on the original MacBook and then appending a string or numeric values, or concatenating by adding plus. As there has been quite a lot of information presented in this section so far, let's try to bring it all together in a single example that will hopefully highlight what we've learned. So here, instantiation of new MacBook, const my MacBook Pro equal new MacBook Pro function closing. Then console.log parameter my MacBook Pro that get price function. It will output 900.00. Then decorate the MacBook, const decorate MacBook Pro equal new case decorator parameter my MacBook Pro closing. And then console.log decorator MacBook Pro that get price function. So this will return 945. Developers enjoy using this pattern as it can be used transparently and is somehow flexible. As we've seen, objects can be wrapped or decorated with new behavior and continue to be used without worrying about the base object being modified. So the decorator, as we've seen, the best example is that we kind of extend, so like with Mixin, it adds behavior without like actually changing the base, but it adds that in runtime rather than in compile time, as we saw here with class case decorator extends MacBook decorator. We extend or we decorate a decorator. So as we've seen, objects can be wrapped or decorated with new behavior and continue to be used without worrying about the base object being modified. In a broader context, this pattern also avoids us needing to rely on large number of subclasses to get the same benefits, or like with mixins. There are, however, drawbacks that we should be aware of when implementing the pattern. It can be significantly complicate our application architecture if poorly managed, as introduces many small but similar objects into our namespace. The concern is that so like another thing is that since we're instantiating a lot of like small things, the disadvantage is that we could introduce a lot of those that has the same thing instead of like referencing the same thing, which you could do in a compile time way, such as Mixin, right? The concern is that other developers unfamiliar with the pattern may have difficulty grasping why it's being used, making it hard to manage. Sufficient commenting or pattern research should assist with latter. However, as long as we handle how widely we use the decorator in our applications, we should be fine on both counts. First, is PJDP interface just TypeScript written in JavaScript? Short answer, yes, but weaker. PJDP's interface, so basically since TypeScript has an interface built in as well, you can think of PJDP as a weaker type of that. So PJDP interface is a manual runtime contract checker. TypeScript interface is a compile time static contract. So this interface is a runtime checker because again it's a decorator, while interface of TypeScript is a compile time. Another thing with decorator is with JavaScript is since JavaScript doesn't have like interface built in, it kinda have to use those interface that is available in other language. Difference: PJDP interface check at runtime, TypeScript interface check at compile time. PJDP interface can still fail in production. TypeScript interface errors caught before build. PJDP interface manual verbose. TypeScript interface native language feature, so it doesn't need to be long and verbose. So yes, PJDP is basically simulating what TypeScript already gives you properly. Second one, your mental model breaks here. Your mental model so far, decorator equal wrap object to add or remove capability at runtime, correct. But then PJDP introduced explicit interfaces, abstract decorators, strict method forwarding, and suddenly it feels heavier. Why? Because the first example were pragmatic decorators. The BJDP version is a textbook classical OOP decorator. Same pattern, different rigor level. Third, what is an abstract decorator really? Forget the ceremony for a moment. So this class MacBook decorator, inside this constructor, parameter lowercase MacBook, inside of this is an object that return this that MacBook equal MacBook closing, and then next in this class is add keys function with an object that return this that MacBook that add keys function, and then get price function with an object that return this that MacBook that get price function. What is this doing? It is a forwarding skeleton. It forwards every method to the wrap object. It does not add behavior. It exists so concrete decorators only override what they change. So basically, this actually does not add behavior, unlike with mixin. It just forwards that. Kind of like with decorator concept, contain forward and then modify. So it forwards that, and then it exists so concrete decorators that want to extend it only override what they change. For example, class case decorator extends MacBook decorator inside of this is an object this with an object so inside this object is a get price function with inside of this object return super that get price function plus 45. So instead of rewriting all forwarding methods every time, so abstract decorator is just a convenience layer to avoid repetition, nothing mystical. So instead of rewriting all of those forwarding methods, you get all of those in one abstract method. So abstract decorator is just a convenience layer to avoid repetition, nothing mystical. Fourth, why the abstract decorator exists, deep reason. Without it, every decorator must re-implement all methods, like class case decorator. Inside this constructor, parameter MacBook, and then inside this is an object, this that MacBook equal MacBook closing. The next line add engraving function, then inside this is an object that return this that MacBook that add engraving function, then closing, then add parallels function, and then the same pattern with add engraving, and then add 4 gig RAM, and then same pattern with add engraving. So that is repetitive and error prone. The abstract decorator centralized forwarding, that's all. Fifth, the thing you cannot articulate, I can see it. So you feel tension because if everything forwards, why do we need interface at all? Exactly. That's the right discomfort. Decorator pattern in classical OOP needs same interface, inheritance hierarchy, strict substitutability. But in modern JS or TS, you don't need inheritance. You only need same methods shape. So if everything forward, why do you need those like interface like to create those abstract? And that's the right discomfort because the decorator pattern in OOP have the same interface. It has hierarchies and the strict substitutability. But in JS and TypeScript, you don't need inheritance. You only need same method shape. For example, this method modern approach interface MacBook. Inside is a get price function with a value number, then closing, then next line function with case parameter MacBook with the type parameter lowercase MacBook with the type uppercase MacBook, then colon with the return type uppercase MacBook, and then return and then inside of this return object is dot spread operator MacBook comma get price function. Inside of this getPrice function method returns MacBook.getPrice function plus 45 then closing. No classes, no abstract decorator, still decorator pattern. That's why PJDP feels heavy. It's modeling Java inside JavaScript. 6. Now the important part, mastery. You said, I want to recognize when to use this in payments, healthcare, etc. Here's the detection rule. Use decorator when, first, you have stable core object. Second, you have optional combinable behaviors. Third, no combinations would explode subclasses. Fourth, you want to attach or remove behavior per instance. Fifth, you want behaviors layered. Example, payment retry system, core, process payment function, optional behaviors, logging, retry, fraud detection, circuit breaker, metrics, idempotency guard. So if you subclass payment with retry and logging, payment with retry and fraud, payment with retry and fraud metrics, you die. So decorator solution, payment equal new retry decorator, parameter payment, the next line payment equal new fraud, check decorator, parameter payment, the next line payment equal new metric decorator, parameter payment. Each layer modifies process payment function. That's enterprise level usage. Let's just continue with number 7 in the next video.